So good morning. Our next topic is about sample and hold. So when we are saying about an sample and hold, actually the thing is to be that we know that the analog signals which are which are constantly changing. So far, a constant circuit will take place over on it. Okay. So the thing is to be that so for a converter, in order to accurately measure the voltage at a specific time instant, so a sample and hold technique which is used to capture the voltage level, and it will be hold it long enough for the measurement to be made. In the acquisition of such a time series, a key role is placed by a sample and hold module. So when you are saying about time, the thing is to be that we'll have a two buffers. They are combined with the capacitors. So and we'll have a logic control switch. So in the S state, what will happen, Abdina? The switch is closed and the input signal passes through to the output. While in the sample mode, the capacitor charge where the Q is equivalent to CV, which continuously changes in response to the input voltage. When the hold command is involved, the switch opens, disconnecting input from output. This freezes the capacitor charge and hence the output voltage at the instant of switch opening. So the variation that provides improved low frequency tracking. So they are commonly used in sample and hold. From a performance perspective, there are a number of real device limitations. So there is four distinct phases of operations which has to be followed. What are the four distinct operations? One to be what will happen during a sample, and the sample to hold transition, and third one what will happen during a hold, and fourth one to be the hold to sample transition. So what will happen when you are having about an during sample? So while in the sample node, the sample or hold is acting as a unity gain device. So the output should exactly follow the input. But because of the finite speed of the amplifiers, the response to a full scale step input will be a delayed output. So typical output slew rates range from output 5 volt per microseconds to several hundred volts per microseconds. So when you are saying about a transient response, so it will be acting as a unity gain device so that the output should exactly follow the input. But because of the finite speed of the amplifiers, the response to a full scale step input. The next process, what will happen? Sample to hold transition. Actually, the transition occurs when the switch disconnects the charge storage capacitor from the input side of the circuit. The finite delay exists between the mode control pulse and the physical action of the electronic switch. The actual switch opening is delayed following the hold command, all moving the capacitor to continue tracking the input for this additional time. Therefore, the hold value is not exactly equal to the input at the designated sample moment. So this delay is known as the aperture delay time. So what will happen? The aperture delay is of 5 to 150 nanoseconds, which are to be common. So what will happen when we are having about an during hold? So actually in during hold, while in the hold mode, the output ideally should remain unchanging, frozen at its initial value. However, the capacitor will inevitably lose its charge, causing the output voltage to drop. Drop for voltage is related to the leakage current from the capacitors. So it is the ratio of del V divided by del T, or we can say that del I leakage to the capacitors. So drops ranging from about zero point 0.1 volt per second to and 100 volt per second are typical, with improved behavior for larger values